Greetings. This screencast will walk through the making of a CFN-NAG rule. In the more recent versions of CFN-NAG, rules are authored in the Ruby language. Therefore, we will walk through a test-driven process for creating these rules in Ruby. There are 4 basic steps. First, we will need to decide upon what features of a template we'd like to have flagged as a violation. Think of this as our mini requirements analysis. In this screencast, we will look for the storage encrypted bit on an RDS instance, looking to confirm that it is set to true. Next, we will generate so-called red and green CloudFormation templates that do and do not contain the features of the template we wish for CFN-NAG to flag as a violation. So in this case, we'll generate a red CloudFormation template that has an RDS instance where storage encrypted is set to false. And we'll also generate a green CloudFormation template where storage encrypted is set to true. Also, we will likely generate a CloudFormation template where it's not specified at all. Then we'll actually develop the rule object in a test-driven way using r-spec. And then finally, we will install a CFN-NAG distribution from RubyGems and invoke our new custom rule through the CLI in order to show how you can extend CFN-NAG with the custom rule. Deep into things, for the sake of this demo, I'm going to presume you have at least a basic understanding of a few technologies. First and foremost, you'll need to have a basic understanding of Ruby programming. You won't need to be an expert or a guru or anything, but you should have a basic understanding of computer science 101 type stuff like decisions, loops, function calls, etc. Also going to presume that you have at least a basic understanding of r-spec and RVM. These are Ruby technologies that allow you to respectively do automated testing and to manage installation of Ruby versions. And then last and least, Bash and Git. We won't focus too much on these tools, but as far as following along, it'll be helpful if you at least have a rudimentary understanding of how these tools work. Let's get started. Let's set up a version control repository to store our rule code and test code in. Whenever doing software development, it's very important to have your work saved in version control so that you can track your history and roll back if you need to. From the command shell, I'm going to create a fresh directory in my home space. Let's call it CFN-NAG rules. I'm going to navigate into that directory, and then I'm going to create the repository using the git init command. Great, so you can see we've initialized an empty git repository here. As far as getting started, to make life a little easier, I've prepared a prototype repository with the basic directory structure that includes a specification for other software modules we'll need to do the walkthrough. So I've made that available in Stelligent's GitHub account. Let's navigate there. As you can see here under Stelligent, CFN-NAG rule repository prototype. So we're not going to actually clone this. We don't want to submit anything here. This is just a starting point. So instead of cloning it, I'm going to download the zip file. And then I'm going to put the contents of that zip file into our own repository for our custom rule development. So as you can see here, the zip file is cfn-nag-rule-repository-blah blah.zip. On my Macintosh here, that'll be in the downloads directory. So let's copy that here. All right, you can see it's there, and let's unzip it. Great, and so it created it under a directory called CFN-NAG rule repository, blah, blah, blah. So let's move all that good stuff up into this directory. And then let's delete the zip file and the underlying directory. So what we should be left with here is a gem file, a lib, and a spec folder. So the gem file is the specification for some of the gems that we're going to need to do our work. So we're going to include CFN-NAG here, even though we need CFN-NAG in order to write the rules against it. The API is in that gem. And then also r-spec for our automated test, and simple cov we'll use to measure our test coverage as we're developing rules. And underneath lib, there's nothing at the moment. It's just a placeholder directory. So now that we have this in place, let's actually add it into our Git repository. Very easy. Add this, and we're going to just call this our first commit. Voila. So now that we have a place to safely store our work, let's take a look at the CloudFormation template that includes an RDS instance. So I've opened up the repository that we've created in the RubyMine IDE. You can, of course, use the editor IDE of your choice. I happen to prefer RubyMine. It's very helpful as far as syntax highlighting and whatnot. So a starting point, CloudFormation template with an RDS database instance is in the prototype repository, and that's what we're looking at right now. So you can see here it's stored under the spec directory, test templates, and RDS_DB instance. So one thing to note here is that it's important to organize the test data. Otherwise, it just gets out of hand as you add more rules. So in this case, the convention is by AWS service and the resource under test. So the service here is RDS, and the resource under test is DB instance. So let's take a look at this guy. It's relatively simple. It's going to create one RDS DB instance. As we highlight the properties block here, you can see that it does not include a storage encrypted field. So we're going to consider this a red template. I believe that the default is false, but regardless of whether it's false or not, there's a certain comfort in having a violation when it's not set to true explicitly. Why leave it to chance what the value is? So we're going to mark this guy red. Let's now make two other templates from this base template. One of these templates will be where storage encrypted is explicitly set to false, and another is where it is set to true. So let's just take a quick look here at the definition for this resource, which again is RDS DB instance. So here in Amazon's documentation, we can see the storage encrypted definition, and it does say that the type is Boolean. However, in my experience, this is a little bit of not the whole truth. I believe that CloudFormation will also accept a string with the same name as the Boolean type. So true versus true in quotes and false versus false in quotes. So let's make sure that we have some test cases for that as well. We could try to double these up, but let's just kind of keep it simple and stupid, and let's just make two more test templates here. So I'm actually going to cheat here. I'm going to copy this, and I'm going to have a very similar name. We're going to call it false string. Copy this here, and let's make this explicitly a string, and we'll do the same for true. Great. So at this point, we've identified the features we want to look at. We want CFN and NAG to look at least, and we've generated some test templates to work against both red and green. So let's finally get down to doing some development. Under the lib directory, let's create a rule object that will encapsulate the logic for finding a DB instance where storage encrypted is false or not specified. As far as the naming goes, we can call it what we like as long as the name ends in rule. But the file name and the class name inside need to match up because of how the rule loading is done. And that rule suffix must be in uppercase. It's initial uppercase. It's case sensitive. So let's type it out here. RDS DB instance storage encrypted rule. Again, you can name it whatever you like, but I do find it helpful outside of the rule suffix itself to name the resource on your test, the service, the resource, and then perhaps some kind of field or predicate that's relevant to what's being tested. Okay. So first thing, we're going to need to require a few files from the CFN-NAG gem. Let me zap this up so that you can follow along easier. So first, we're going to need to require the CFN-NAG violation object, and then we will also need to require a base rule that we're going to extend here. Don't worry too much about this just yet. It should become more obvious as we start to write a little bit of code here. Right, so violation and the base rule. So first things first, let's define a class. Again, we have to name it the same thing as the file that contains it. So let's just swipe that so we don't have an error. And we want to derive from the base rule. Now, as far as the heart of the matter here, audit impl is going to accept the CFN model object. This is the heart of the matter here. We're going to leave this blank right now because we're going to develop tests first to drive the development. Aside from the heart of the matter, there's a few callbacks that we can go ahead and define right now. So there's three callbacks: rule text, rule type, and rule ID. These are callbacks that the CFN-NAG core rule engine calls while it's running through the rule evaluation. So these should hopefully be fairly self-explanatory, but to elaborate, def rule text is going to be the text that is emitted when this rule finds a violation. CFN-NAG will call this and pull this text out and emit it to the user. So in this case, we want to say RDS DB instance does not have storage encrypted set to true. Our rule type, here's where our violation require comes in. Rule type can either be a warning or a failing violation. So let's make this a failure. I think encryption is a pretty big deal here as far as security goes. And then last but not least, we have our rule ID. You can identify this any way you want to. I've been following a convention that failing rules start with F and warnings start with W. And then I've been using concatenating it with a unique number. Let's just pick an arbitrary number here. The numbers that are in the core CFN-NAG product are fairly low, so if you just pick a large, high number here, you should be fine. The point for these identifiers is to identify rules when they're included in profiles, which are rule sets. So when you get to the point, if you only want to apply a certain subset of rules for your organization, then that's where this will come in. Great. So an object in place to test, let's go ahead and write a test. So under the spec directory, let's create a file with the same name as the class or object under test, but with the suffix ._spec, excuse me. All right, to get started, first we need to require a few things. Spec helper is the first thing we'll require. It includes some of our code coverage stuff, and any common test methods will end up being put there. We also need to require CFN model, since we'll be manipulating, we'll be parsing a template and parsing it into a CFN model object that we'll be manipulating. And then finally, let's require the object under test, which is the RDS DB instance storage encrypted rule. Great. So this spec is really describing the behavior of the vacuous class we just created. So we're going to capture the fact that it's describing that with, guess what, a call to describe. And we'll give the class name and a block. Then we need to describe an initial condition for some test. In this case, we're going to take the base template, which is an RDS DB instance where there is no storage encrypted bit even specified. Let's make that the initial condition. So we'll call context and say when RDS DB instance has unspecified storage encrypted. And then finally, we want to say what's going to happen when we run the rule. So it returns logical resource ID for offending DB instance. In reality, we're testing the method audit_impl, but given this rule object's pretty simple and audit's really the main event, we kind of skipped out on that. So the way you do that is you could add a second nested describe under the first describe, and that describe could describe pound to audit_impl. But we're not going to do that. So great. Now we've got the it declaration here. Inside the it block, we execute the object under test and measure its expectations. This is where the stuff's actually happening. So the test for CFNAG custom rules typically has some very similar steps. There's about 4 of them. Instead of switching back to a slide and disturbing our workflow, let's just write them here as comments, and then we'll match the code to go with them. So your first bit is to load the test template into a CFN model object. Next, we need to instantiate the rule. That rule being the object under test. And then we're going to invoke audit against the rule object with the loaded CFN model object. This is really at line 11 of this comment. We are actually calling audit against something, and we're expecting to see some sort of violations or no violations come back. And then, finally, measure our expectations. So as far as writing the code for this, let's actually go leverage a prototype. Once again, we have the trusty EBS volume has a server-side encryption rule. Let's use this code to get us started. Paste it here. By the way, again, CFNAG is open source. All this code is available under the Stelligent organization in the CFNAG repo. Okay, so we've got a bunch of code here. Let's line this code up with the comments. We have to tweak this code a little bit. It's using a helper method here to load the test template that we don't have access to. We don't need to mess with that, so let's just change it to an IO read. And we have the test file we want under spec test templates, RDS DB instance, no storage encrypted YAML. Okay, so at this point we've loaded the test template into a model object. Now let's instantiate the rule and invoke audit against that rule. So let's move this up here, and obviously we want to use our rule, not that rule. So this one line covers both of these 2 comments. You can see here we're instantiating it, and then we're calling audit_impl with the CFN model we created on line 9. Finally, let's measure our expectations. So the expected logical resource IDs are not going to be new volume 1 and 2. Let's go take a look at our test data and see what the logical resource ID is. So it's really important DB instance. Let's copy that, bring it back to our rule. We'll make an array here with just the one element. And then line 18 still follows because it's written in a fairly generic way. We expect that the actual logical resource IDs returned by the audit method on line 13 match with our expectations specified in line 16. Okay, with our test in place, let's go ahead and run it right now. Boom. And as you can see here, it failed. And that's what we wanted. We expected really important DB instance to be returned as a logical resource ID, and instead we got nil because obviously we haven't implemented anything yet. So the default return value for an empty method will be nil. All right, so let's make it pass. Down in the code here, we're back at our custom rule. So let's start filling in the audit implementation. First thing that our logic's going to need to do is to retrieve a collection of all the RDS DB instance resources in the model. So the CFN model object that's passed into our audit method has methods to query and retrieve that sort of information. So we're going to ask, we're going to send it a message. We're going to ask for all the resources by type for the guy we care about, which is the RDS DB instance. Okay, so this will return all of them. We don't want that, right? We need to filter this down into the resources that we actually care about, the ones that are not meeting our compliance rule. So this is a collection, so we can do a typical Ruby select on this. And then for every instance, let's take a look at whether storage encrypted is nil or whether it equals false. So just to recap a little bit, the storage encrypted attribute on this resource object is something that maps directly from the properties definition in the CloudFormation user guide. Basically, every properties field you see there will be a direct attribute on a resource object returned by resources by type. So let us assign this to a value. These are our violating resources, even our violating instances. And then finally, what we need to do is only return the logical resource ID. So we're going to iterate over this, and we're going to map it in a typical Ruby style. Violating instance. And then logical resource ID, again, will be on every single resource returned by resources by type. As far as learning what these attributes are, you can follow some of the other rule examples that are in the CFN NAG core. It's actually, this object comes from another package called CFN model, which aims to simplify some of the rule development that we're doing here. There's less nil checks, less array checks, less optionality checks that we have to deal with. CFN model kind of hides most of that from us. For the most part, I believe CFN model follows pretty natural from the underlying CloudFormation template. Okay, so we've actually developed a rule here. So that's all there was to this. Let's go back to our test now and let's see if it passes. And voila, it's passed. We're green. So we went from red to green. Okay, now that we've got our test passing, let's iterate on this a bit and specify a new test. So if you recall, we defined several other test templates as far as being, this is the one with the implicit value, which is a red template. And then we defined two false templates with explicit false. So let's actually capture that too. So we kind of did this backwards, actually. So let's kind of violating the very incremental test-driven development process. Let's actually go back and undo something that we did. When storage encrypted is nil, this is the one that we actually wrote the test for. We didn't write a test for this yet, so we're cheating. Let's just take that out for a second, because we basically want to see that the test fails first before we make it pass. That's our way to know that the test didn't just pass just because of some kind of coincidental feature of the software. Right, so here we are. So we're adding a new test here. Let's elide that one. So when RDS DB instance has storage encrypted equals false. Okay, and all we need to do, the rule is very simple, and there are ways to maybe make this code less repetitive. We're not going to worry about that right now. Let's just update the file name here for our test template. So I believe it is DB instance storage encrypted false. Okay, so let's run the whole kit and caboodle. Let's run the whole kit and caboodle again. Whoops, I made a mistake in here. And there it is. Sorry about that. And boom. So one failed, one passed. So our old test passed, our new test failed. Great. Let's go in, put this dude back. Dude, how professional. And let's run our tests again. And voila. So it's green. That's great. Let's do one more iteration on this. So we created a test template where it is a false string instead of a false Boolean. Let's update the file for that. And let's run our tests again. Boom. Oh no. So 2 passed, 1 failed. Our new guy failed. And the reason it failed is because it's a false string, not a false Boolean. So let's, even if it is a Boolean, let's turn it into a string and compare it against this. And we'll run all our tests again to make sure we didn't cause a regression with our other check. And there we go. We've got all 3 tests passing. So from here on, I guess the other thing we needed to test is that resources that are okay are not flagged. So let's actually swipe one of these guys here, and I'll elide it. And let's say when RDS-DB instance has storage encrypted true. And then from here, we're going to say true. But now we're going to change our expected logical resource IDs. We don't expect anything to come back from this as a violation. Great. And we'll do the same thing. Actually, sorry, let's supplement that. False string. As a true string. All right, and we'll update our template. And once again, we are expecting nothing bad to come back. Excellent. So we've got 5 tests, and they're all passing. Our rule is ready to go. And call this done. Let's measure our test coverage to make sure that we didn't miss anything as far as testing goes. The amount of code is small, so this likely won't reveal anything mind-blowing, but it's a good practice, and it's definitely important for when we develop more complex rules that include more branches or more loops. Great. So let's start from scratch with a fresh Ruby here, fresh gem set, just to make sure that our testing and our coverage isn't influenced by any of the work we've done previously. So let's call this CFNX screencast. We'll create this. We'll install bundler. Bundler is going to install CFNag and r-spec and all that good stuff based upon the gem file that we looked at previously in the root directory of our prototype repository. All right, so let's bundle install. And now let's call r-spec. Yay, 5 examples, 0 failures, what we expected, what we saw through the IDE. And you can see here at the bottom that a coverage report was generated. 76.92%, smaller than I would have expected, but let's go take a look and see why that's so. You can see here we have the one file, 76.92. So the good news here is all pretty much good news, but the good news is audit impl, which is what we were testing against, is fully covered, well covered. The rest of these callbacks weren't covered, and that's not a big deal. These are methods that are obviously don't even have any logic in them, really. They're just strings, and they're called by the core engine. We've finished doing our unit testing, and we're feeling pretty good about the test coverage. One thing left to do before we declare total victory is to do an end-to-end test using the CFNag CLI. This is basically the ultimate confirmation that the custom rule we've developed is going to behave the way we want to. So we've previously installed the CFNag gem as part of previous development efforts. Let's invoke the command line, and we'll give it the rule directory, which is our lib directory here. And then we'll pass it in a template that we know should evoke a violation, the same templates that we used in our unit testing. And there you go. you see that the really important DB instance is flagged as a violation because it does not have storage encrypted set to true. And just to show you the flip side, let's invoke the CLI again, but this time we should get no violations, and voila, we get no violations. This is great. Both our unit tests and our integration tests, we're ready to commit our work back to the master branch. So first, let's take an inventory of all the files we've changed. Make sure we didn't inadvertently change anything we don't want to commit. As we can see here, we've got the rule code, we've got the test code for the rule, and then we've got the 4 test templates that feed the test code. All looks good. Let's add it. And that's it. We're done. So we've committed our work, and that's that. So what I've done here is taken you on a test-driven tour of how to create a custom rule for CFN NAG. If you have any questions about this, I can be reached through the CFN NAG GitHub repository at Stelligent. That's Stelligent/CFN_NAG. Have a nice day.